So here's what we're saying here. We are saying if they gave us the following question and then they say determine the general solution. When they say determine the general solutions, they want all the solutions whereby when tan of theta is equal to 2. In other words, we said if we write this in a function form, we're going to have y is equal to the tan of theta. Now, where we see y, we put 2. Okay. So what are they asking here? They're asking what are the values of theta that are going to give us y as 2? That's the question. What are the values of theta that are going to give you y as 1 as 2? Now, if you go and draw the graph of 10, this is what you're going to see. You're going to see a graph of 10. So this is a basic 10 graph. It looks like this. What are the values of theta that are going to give us 2? All these values, when y is 2, you can see y is 2 here. Y is 2, y is 2, y is 2. Where this graph intersects, y is 2. Where there's an intersection, there's a value of theta which corresponds with y being 2. Again. So we know how to get those values in the first cycle. Let's go to the first cycle. We know how to get those values on the first cycle. So on the first cycle, you can have something that looks like this. You can have 0. And then we go to 360. Now, y is 2. And when y is 2, how many values are going to give us 2 here? How many values seems to give us 2 here? There are 2. So from 0 up until to 360, which is the first cycle, we're going to get 2 values which are going to give us what? 2. Now let's go and find what are those values. We can check them here graphically. I can just put a point here and say, okay, what is going to be this point here? And what is going to be this point here? Let me erase this so that you'll see what I'm talking about. What is going to be this point here? Here. When this is 2, what do you get? 1.99 is approximately 2. And then we can also have another point here. When this is 2, what is going to be the approximate value? Okay, now how do we get those values? How did we do it? You know, we said, okay, we're going to say that we have the tan theta, which is equal to 2. Theta is going to be given by the tan of 2, which then says, if we type this in our calculator, we're going to get, as we saw there, we're going to get approximately shift the 10 of 2. It gives us 63,43. Now, this is not the only solution that we have. As we saw, how many solutions did we have in the first cycle? 2. So where are we going to get the other solution? We're going to say, where is tan going to be positive? Where is tan going to be positive? Where do we expect our tan to be positive? So we're going to say 10 is going to be positive on the first quadrant. So we have theta, which is going to be equal to 63 and 63,43. And then it's also going to be positive on the third quadrant. So according to the third quadrant, we say this is our angle. Let's not forget. So we have theta, which is going to be equal to 180 degrees plus 63,43. And then if you type that in your calculator, what are you getting? 243,43. Now, what is the solution that we got here, guys? This is not the general solution. This is the solution for the first cycle. Do they want the solution for the first cycle? No, they want the solution, generally speaking, for the second cycle, for the third cycle, for the fourth cycle, and so on and so on. So how do you get all the cycles? You are going to use the first cycle to get the others. How do you get it then? We're going to say, according to the first cycle, if I can just add k multiplied by 180, since it's 10 again. And then I'm also going to come to this one and say plus k multiplied by 108 here, since it's 10. If it was sine, what was I going to add? 360 and what? I'm going to add 360 if it's sine and what then? And cos. So this is how we determine the general solution. And then as I was saying that, let's just choose one here and determine the general solution. Let's do number